What you're looking at is the most popular problem ever published in the American Mathematical Monthly. It was contributed by P.I. Chessin and published in the April 1954 issue of the magazine. As you can see, the problem's nickname, the Lonesome 8, is very appropriate. Of the 34 digits represented in the long division problem, only a single one is made clear. It's a solitary 8, serving as the third digit of the quotient. At first glance, does it feel like something one could solve? There's certainly a concerning lack of information. What's more, the problem itself is far from what we might call simple. Looking at the image, you can see an 8-digit dividend and a 3-digit divisor. When you consider that every single digit could be anywhere from a 0 to a 9, a total of 10 possible options, the sheer potential of the problem becomes clear. The only real way to approach something like this is carefully, logically, and methodically. For instance, what we just said about each digit isn't exactly true, is it? Well, the first digit of each number can't be a 0. They can only be represented by 1 through 9, giving us 9 possibilities for those two numbers. So the total possibilities are 9 times 9 times 10 to the 9th power equals 81 times 10 to the 9th power. Whatever your math skill, that is still a staggering amount of outcomes. But what if I told you that this problem is actually quite a bit easier than it looks? In fact, what if I told you that you only need a few elementary insights to complete it? Go ahead and pause the video and give the problem a try. Welcome back. Did you have any luck? Did you get any of the digits filled in at all? Or are you, like most people, simply overwhelmed by the problem's presentation? But if you look at the long division very carefully, the answer will actually reveal itself. Let's go through it step by step. You can see that 2 digits are brought down instead of 1. This only occurs when the second digit of the quotient is 0. Following that same train of thought, we can quickly discover that the fourth digit is also 0. Suddenly, the 8 in our quotient has a little more company in the form of 2 zeros on either side. Now let's look at the section highlighted in red. Here, we can clearly see a 4-digit number being subtracted by a 3-digit number, resulting in a 2-digit number. This tells us that the first digits of the first number must be a 1 and a 0. On top of that, it tells us that the first digit of the second number needs to be a 9. Extrapolate this same idea into the next section, and you'll see that it basically repeats, giving us another 1 and 0, followed by yet another 9. Now it's time to go back to the original number 8 in the quotient. Compare that to the number 9 we've just uncovered, and you'll quickly see that the first digit of the divisor must be a 1. What's more, this tells us that the divisor must be smaller than 125. After all, 125 times 8 equals 1000. So if the divisor were greater than or equal to 125, the product of the divisor and 8 would be a 4-digit number rather than a 3-digit number. But let's just store that information in the back of our minds for now. In the meantime, let's move on to the product of the 5th digit in the quotient and the divisor. Since it's a 4-digit number, we know that the 5th digit of the quotient must be greater than 8. This leaves us with only one logical option, the number 9. We've already determined that the product of the first digit of the quotient and the divisor is a 3-digit number starting with 9. Using the same logic, we can determine that the first digit of the quotient must be an 8. In just a few steps, and only using simple logic, we've determined that the quotient must be 80,809. And since we know that the divisor is a 3-digit number smaller than 125, we suddenly find ourselves very near the final answer. However, we also find ourselves seemingly out of clues. After all, we've done a lot of detective work to get here, but where do we go next? As you'll see, this is the tricky part. To finish the problem, we need some outside-of-the-box thinking. You see, we know that the dividend is an 8-digit number, but if you look closely, you'll see that this actually tells us that the divisor has to be greater than 123. Why? Because 123 times 80,809 only gives us a 7-digit number. Go ahead and pause the video so you can check it with your calculator. See, a number greater than 123 and less than 125, we're left with only one option, 124. Once you have the quotient and divisor in place, Filling in the rest of the numbers is pretty simple. After a few seconds of rather simple math, we finally have our dividend, 10,020,316. Looking back at how we derived all of this from just a single, well-placed number, it's clear how clever P.I. Chessin was in devising this problem. No doubt the people reading the American Mathematical Monthly in April 1954 felt the same way. And they didn't have YouTube to help them out. If you like this challenge, please feel free to share it with others. Anyone who knows how to do long division has everything they need to complete this problem. And if they struggle, go ahead and show them this video. Don't forget to like and subscribe for more ingenious challenges like this. Happy thinking, everyone!